Okay, how's everybody doing today? Doing all right. Okay, we got a full class, that's good. Because today we're gonna do the midterm review. So we're gonna start with a quick review of Watt's law that we talked about last time. So we'll talk about its basic form, and Watt's law is all about power, so we'll remember what power is. And then we'll see some of the alternate forms for Watt's law. Then we'll move on to the main topic, which is the midterm review. So first of all, we'll talk briefly about the format and the rules for the test, and then we'll cover the objective for the test, which is just to find the voltages and currents for a particular circuit. So I will draw that circuit on the board, and we'll do some practice math to see how you can use math to find out those voltages and currents. And then I will also show you how you can build a physical circuit on a breadboard and how you can measure the voltages and currents that you need there. Okay, so we'll do all of that, and then we will do just a little bit. I want to go over some instructions for actually entering the information in the Canvas quiz format that you will be using during the midterm. And then for lab, hopefully this lecture will be relatively short. And then for the lab time, we'll go over to the regular lab rooms, and you'll all get to practice this. So you get to practice doing the math, doing the physical boards also, and entering the data into Canvas. Also, this the practice Canvas midterm, or the practice midterm, will be available on Canvas now. It's really, honestly, it's been available the entire semester, and it will continue to be available throughout the rest of the semester. So if you feel like you'd like a little bit of extra practice with it, you are welcome to take it at home as well, just to help you prepare for the midterm. So that's the goal for today. That's what we'll be working on. Are there any questions about that? Yeah.
I looked at the practice, and there were some questions that we didn't cover yet. So
okay.
Yes, we can still take it.
Yeah. So there's a couple of practices. The practice midterm should just be that one circuit. There's also a practice final, which will have multiple choice questions, but we're not going to be doing that until the end of the semester.
That was final.
Yeah. So yeah, there's definitely some stuff that we haven't gone over yet for that.
Okay.
Sure.
For the practice midterm, is it pretty similar to what the actual midterm is going to be like?
Yes. So yeah, basically for the midterm test, what you'll be doing is that you will get a diagram of a circuit that's in that format that we've already seen, and I'll go over it again in just a minute. You'll get a diagram like that. The test will show you what resistor values to use, and then you will find those voltages and currents based on that circuit. And yeah, I'll go over that in a little bit more detail in just a minute.
Be a ton of Ohm's law?
Yeah, basically, yeah. I'll go over the math in just a minute, yeah. First, though, I wanted to do a quick review of Watt's law. So Watt's law was all about power, and really it's more of a definition, I would say, than a fancy formula. Really, Watt's law is power is voltage times current. That's it. So it's really a definition of power in electronics. Sometimes it's written power is V times I. P equals V times I. So what is power? Power is really just the amount of energy that's being used at a particular instant. So that energy can be going towards something that you want, like lighting up a light bulb, creating light, turning a motor, making sound come out of a stereo. Power can be used for those helpful things, but power can also be wasted in the form of heat. So anytime electricity flows through a resistor, there's voltage across that resistor and current flowing through it, so that's creating power there as well. And that power isn't doing anything helpful, really, but it's just being turned into heat. So it's important to be able to calculate power because you need to be able to know how much power, say, a stereo system requires in order to give it enough of a power supply to do what you want. You would need to know how much power a motor requires in order to make it turn. And you would also need to know how much power is being used up by your resistors so that you, first of all, you don't get too much heat inside of your circuit board, and also so that you provide enough of a power supply, again, to make your circuit do what you want. So that's what power is. That's why it's important that we know about it. And then there were a couple of alternate forms of Watt's law. So if we know the voltage and the current, we can use this form, but sometimes we just know the voltage and a resistance. So if that's the case, then you can use this other form. Power is V squared divided by R. Or sometimes you just know the current and the resistance. And in that case, you could use this form. Power is I squared times R. So you can use any of these forms you want. It just depends on what information you have. Okay? Yeah.
Is this an open exam?
Yes. Yeah. So any other questions about Watt's law? Okay. All right. So then, yeah, let's go on to the format and the rules for the midterm. So the format for the midterm is that it's going to be in class. So you'll all come to school at the normal time, so 9 o'clock on Thursday. But we're going to meet over in the lab rooms instead of meeting here in the lecture. So everybody's going to meet over there at 9 o'clock. In fact, it might be helpful to come a few minutes early just so that you can get settled and ready, and then the test will actually begin at 9. Every person will take the test by themselves. I know that during the labs you've been working together, and that's great. That's what we want. That's very helpful during the lab times, but this test is going to be a test of your own personal skills and abilities. So for this test, every person will be working by themselves. You're not allowed to talk to your neighbors. This is purely your own work. And you will get to do the math and build the boards on your desks and do all of that stuff in the classroom. But you will enter the results from your work in an online quiz. And actually so when it's 9 o'clock, you'll pull up the quiz. That will tell you which resistor values to use. So you'll go and find those resistors, and then you'll build your circuit, you'll do your math, and then you'll enter your data right into that online quiz. And then when you're all done, you'll hit submit, and the quiz will be graded for you automatically. Okay? So that's the format for the test. The rules for the test are that you can bring one sheet of notes. So you can write whatever you want on one piece of paper. You can write on the front and the back. You can write as small as you want. You can use a calculator. You can use a pen or pencil to do calculations also. I'll give you scratch paper if you want to use scratch paper for doing some calculations. During the test, there's no talking and no cell phone use and no internet other than the Canvas quiz. So those are the basic rules for the test. Yeah?
Can I use the calculator on the computer?
Yes, that's okay. Yeah.
Is there like certain calculators that aren't allowed?
Anything that doesn't have internet connectivity is okay. Yep. Yeah.
Did you say it was Tuesday or Thursday? The
I'm
test.
I'm sorry. It's next Tuesday.
Okay.
I must have mistaken. Yeah.
17?
Yeah.
This,
This coming Tuesday. This coming Tuesday. So our next class. Yes. Thank you.
How long?
double check.
Yeah.
How long do you suspect the exam will take? Like how long do you design it to take?
It's different for everybody. You may take up to the full 3 hours of the time that we have on Tuesday, but everybody, you just take as long as you want, and you can go when you're done. Yeah.
You said that the quiz was like auto-graded once we put our answers in. Will that account for like if everyone's resistors are kind of different or different, like things that might not be the same for every person?
So, right. So each quiz will be different. So you might have a 500 ohm resistor and a 1,000 and 200. Your neighbor might have a 300 and 800 and 600. So each quiz will have their own resistor values, and each quiz will be graded based on the values that are given to you.
Okay, but if our actual resistors, since the tolerance might be off, is it going to account for that, or
Yes.
should
So
we just assume that it's what the label is?
So what the quiz will do is that it will make calculations based on the ideal resistor values, and then it will find the ideal answer, and then there will be a tolerance around that ideal answer. So as long as you are within that tolerance, you'll be okay. So use whatever resistor values you actually have. That being said, the rounding that we talked about last time is important. So if you have a resistor that is 1,263 ohms, we said we want to try and keep usually about 3 digits. So you could call that a 1,260 ohm resistor, and that would be fine. But if you say, oh, well, that's about 1,000 ohms, no. You've rounded too much, you've thrown away too much information, and that would probably give you a wrong answer. So so pay attention to your roundings. Yeah.
You said when we're doing like moving numbers, like calculating things, that we would use the 4 digits, right?
Yeah, in the middle of a calculation, I would keep 4 digits. Yeah. Yeah.
Can I ask how many questions there are?
Well, so we're going to have that circuit, and I'll draw it in just a minute, and there's 4 resistors, and you need to find the voltage and the current for each resistor. So and as well as the total voltage and total current. So I don't know if you call that one question because it's just about one circuit, or you could say that there's 4 volt or 5 voltages and 5 currents. So you could call that like 10 questions, but that's what we'll be working on.
Oh, it's based on one circuit.
One circuit.
Oh, okay.
Yeah.
Gotcha.
Yep. Yeah. Are there questions? Okay. All right. So we talked about the format and the rules a little bit. So let's talk about the actual circuit. So the test will be that you will have a circuit like this. It'll be 12 volts. There will be a resistor here, one here, one there, and then one more over there. And each person will be given their own resistor values, and you'll be asked to build this circuit and measure the voltages and currents for each of the resistors. So, so what I will do is I'll use some example resistor values here, and we'll go through the math for how we could do that. And then I'll also show you how we could build this on a circuit board and make the measurements that way. You are welcome to get your answers in whatever way works best for you. I would recommend getting them both ways. So building the circuit and taking the measurements, and then also doing the math for the circuit and comparing your math answers to your measured answers. That way, if the math and the measurements are very similar, you know that you're probably on the right path. If the math and the measurements are off from each other, that might be a sign that you want to go back and check your work. Okay? So let's do this example. Let's say that we have 300 ohms up here. We have 300 ohms there, 600 ohms there, and 100 ohms there. So for this circuit, we want to figure out the V total, I total, R total, and then V1, all the voltages, and then all of the currents as well. So that's what you're going to do for the midterm. So let's work on it. So do we have to do any calculations to figure out the total voltage? No. That's just the voltage that comes from the power supply. Whenever we say total voltage or total current, we're just talking about the voltage or the current that's coming from the power supply. So that's just 12 volts. We'll call this R1, R2, R3, and R4. Okay, so now, what would be the next thing that I might want to try and find for this circuit?
Equivalent resistance.
Yeah, the equivalent resistance. So is this a series circuit, a parallel circuit, or a series parallel? Perfect. All right. I love that. All right. So then can we just add up all of the resistor values to find the total resistance? No. What do we have to do?
The
Yeah.
number of resistors and then divide that by the number of resistors.
Well, yeah. So we can look for resistors that are in series or parallel and then find their equivalent resistance. Yeah.
You can simplify R3 and R4 and find the equivalent.
Perfect, yeah. So R3 and R4 are in parallel because their tops are connected to each other and the bottom resistors are connected to each other as well. So yeah, so we can simplify those. I love that you go there. Some people get a little bit confused and when you look at this circuit, it almost looks like R1 and R3 and R2 are in series. So some people start thinking about that, but that's not the case because remember, in order for something to be in series, it has to be, the end of one has to be connected to the beginning of the next with nothing in between. And you can see that R4 is connected between R1 and R3. So just like Stephanie said, R3 and R4 is the place to start here. So, so here we have 300 ohms and 600 ohms in parallel. So to find their equivalent resistance, we have to use that parallel resistance formula. So we say R, and let's call this R34 because it's a combination of R3 and R4. So R34 equals 1 over R3 plus 1 over R4. Okay. So 1 over, that is 1 over 300, and then 1 over 600. So what is 1 over 300? Does somebody have a calculator? So I think it starts with a decimal. So point 0.033 or just 0.3? Yeah. 0.0033 like that? Repeating? Yeah. And then 1 over 600 comes out to be 0.00166, I think, repeating. So if we add those together, that's 1 over 0.005, essentially. So then our total equals, what is 1 over 0.005? 200. Sorry, and this isn't our total. Sorry, it's R34. So R34 is 200 ohms. So any questions about how we got that? Yeah.
For 1 over 600,
Uh-huh.
you did 0.00166.
Yep.
Is there a reason why you didn't round the 6 to 6.7?
So yeah, that's a good question. I could have rounded that. When you have a little line over a number, that just means that number is repeating forever. So that's a kind of a shorthand way of saying that number repeats forever. But yeah, you're right. You could have rounded that to 0.67 also.
Since we're talking about rounding.
Right. It's a good way to practice that. Yeah. Thank you. So there we go. And this could be rounded to 0.00333. All right. Yeah. Great. Other questions? No. So there's this concept called significant figures, and we kind of skirted around that. We talked more about rounding than that anyway. I don't want to get into that too much, but no, the answer is that they don't.
You said just don't. It's like after the zeros, keep the 3 leftmost digits that don't start with 0.
Yeah.
Okay.
So that's what we did here. So we had 2 zeros to begin with, and then we kept the 3 leftmost digits that were not 0.
Okay.
Yeah, it didn't start with 0. Okay, so that's how we got R34. So then what we can do is that we can redraw this circuit with R3 and R4 replaced by that R34. So we still have 12 volts here. R1 and R2 are the same. But now we've replaced these two resistors on the right with one equivalent resistance. And that is 200 ohms. So, any questions about how we redrew the circuit? Okay, so now we're still trying to get down and find that one equivalent resistance for the whole circuit. So what can we do now?
Add them all up and divide it.
Yeah, we can add them all up because they're all in series now, and that's the way that you find an equivalent resistance for a series circuit. So we just add these all together. So our total is R1 plus R34 plus R2. So that is 100 plus 200 plus 300 just comes out to be 600 ohms. So that's our total resistance. And we could redraw this circuit with just that single total equivalent resistance. So any questions about that? Okay. Yeah.
Was it just a coincidence that we did all that math for the 300 to get down to 200 because if we divide 6 by 3, it's 2? Is that just a coincidence?
Well,
Remember we did R2 and R4? And
so if you have resistors that are all the same value and they're all in parallel, then you can take one of those resistance values and just divide it by the number of resistors to find the total. But in this case, we don't have the same resistor values. They're different values, so we can't just divide by the number of resistors. That's why we had to use that.
if you divide the 300 by 600, you get 200.
No.
I mean 600 by 300, you get 200.
You would 600 over 300 is just 2.
Oh,
It's not 200. So yeah, when you have different resistor values in parallel, you need to use that parallel formula. Yeah. Yeah, other questions? All right. So now we have the total resistance and the total voltage. What could we find next? Yeah, the total current, exactly. And what law do we use for that? Ohm's law. Perfect. So we remember Ohm's law is like this. We've got V, I, and R. So if we want to find the total current, we write down I equals, we cover that up, we see it's V over R. So in this case, we're talking about totals. So we want the total voltage over the total resistance. So 12 volts over 600 ohms. What does that come out to be? Okay, perfect. So 0.02 amps. Now, yeah, I know that when I put my numbers into my formula and I use raw units going in, like volts and ohms, then I get raw units coming out. It's important to put raw units in. So if I had kilo ohms or millivolts or something like that, you would want to convert them into raw units before you do your calculations. And then once you get your answer, that comes out in raw units. But then once you have that, you can convert it if it's more convenient to write it another way. So this is 0.02 amps. How many milliamps would that be?
20.
20.
Yeah, 20 milliamps. So over here, we can say that I total is 20 milliamps. So that's the total current that's flowing through this circuit. In other words, it's the current that's coming out of the power supply. And since these circuits are all equivalent, if we know that we have 20 milliamps coming out of this power supply, it's the same. There must be 20 milliamps here, and also 20 milliamps here. Okay?
Okay, so I have a question about this. If we were just gonna reverse, like just figure out V to make sure everything was right, like do 600 times 0.2 or 0.02, is that the way that you would do it? You wouldn't do 600 times 20, because that would come out to way too high.
Correct, correct. Anytime you do your calculations, you want to have the just raw units, going into the calculations. Yep. Yeah, other questions? All right. Cool. So now we know the total voltage, total resistance, and total current. What should we attack next? What's that?
Use this to treat them like voltage dividers, right? And then find the voltage of all the resistors. Since we now know that we can find the voltage of the top and the bottom.
So yeah, that'd be an interesting way to go. So we could look at this and say it's like a voltage divider. So yeah, we could find the voltages across the resistors that way. Yeah. So let's give that a try. So we had that voltage divider formula, and we said that the voltage on a particular resistor, say R1, is the total voltage times R1 over R total. So in this case, what's the total voltage?
12.
Perfect. So 12 volts. And then what is the resistance for R1? 300. Perfect. And the total resistance is 600, right? So that's 12 volts times a half. So that comes out to be 6 volts. So we have 6 volts there. We could do the same thing for the bottom resistor. So that would be the voltage for R2. So that's now 12 volts times R2 over R total. So that would be 100 over 600. So that's a sixth of 12. That comes out to be 2 volts. So we have 2 volts there. And then, what's that?
I have 4 left.
That's exactly right. Yeah. So all of the voltages around this loop have to add up to 0. In other words, these resistor voltages have to add up to the 12 volts of the power supply. So like you observed, we've got 6 volts there, 2 volts there, that's 8 volts. So the rest of the voltage, or 4 volts, has to be across that resistor. So questions about that? Yeah.
There'd be no difference if they had different resistance between those two? R3 and R4 being different ohms doesn't change the voltage for both of them being 4 volts? Correct.
R3 and R4 both have 4 volts across them. because they are in parallel. And in parallel circuits, the voltages are always the same across the elements. Another way to think about that is that in a parallel circuit, you've got a wire going all the way across the bottom, and voltage is always the same along any wire. So all the voltage along the bottoms of all of the components are the same. And similarly, along the top, you've got a wire, so you've got a constant voltage along the top of the component as well. So we just figure out the voltage across R1 is 6 volts. The voltage across R2 is 2 volts. And then voltage for R3 and R4 are both 4 volts. Now what about currents? It looks like we just have currents left. So how can we figure out the currents for these resistors? Yeah.
Divide the voltages that you just found by their individual resistor values.
Yeah, so that's a good idea. Perfect. So so we can, for R3, let's look at R3. So we want to find the current for R3. So we write down I equals, cover that up, we see it's V over R. So I3 is V3 over R3. So V3 is 4 volts. And then R3 is 300 ohms. So what is 4 over 300? Somebody have a...
13.3 milliamps.
Okay, so 0.0133 amps. Yep, so that equals, 13.3 milliamps. Yep. Okay, perfect. So, okay.
What made you want to start with I3?
I'll get there in just a second. So that's I3. So we could do the same thing for I4 also, right? So I4 is V4 over R4. And so V4 is also 4 volts. And then R4 is 600 ohms. So that comes out to be, should be 0.00667 amps, which comes out to be, or which is also 6.67 milliamps.
I'm so confused. Why? Like, this is a basic math thing, but
Mhm.
if 4 out of 100 is 4, why is 4? Why wouldn't it just be 12 out of 300 for the? I'm just like confused how we got 13 and not 12. Because if 4 out of 100 would be 4, it should be like, it should add up to 12 in my head for some reason. I'm just like,
You're just thinking about it. It's not 4 out of 600, it's 600 out of 4.
oh, okay.
That's
I'm
the
just thinking of it
progressive
backwards. Okay, thank you.
Okay, cool. Okay. All right. So those are the currents that we have for resistor 3 and resistor 4.
I3 is what?
It's 13.3 milliamps, and I4 is 6.67 milliamps. It's 6.67 should be. So let me, okay. So what I think is that we've got about 13.3 milliamps there and 6.67 milliamps there. Now you asked me why I started with I3 and I4. Why not maybe I1 or I2? So do we have to do any calculations to find what I1 is?
No.
No, exactly. And so what can we do?
20 milliamps.
Yeah, we know that it's 20 milliamps because we have 20 milliamps coming out of this power supply, and that 20 milliamps only has one path to go down. So all of it has to go down that path, which goes right through R1. So we have 20 milliamps flowing through there. And how much power or current is flowing back into the power supply? 20 milliamps, exactly. We always have the same current flowing into the power supply.
You know, R1 and R2 already have 20 milliamps.
Exactly. So R1 and R. So since we have 20 milliamps going back into the power supply, we know that all of that has to be coming through R2. So we must have 20 milliamps there also. So that's why I didn't do calculations for R1 and R2 because we could just see that. Okay. So then we can just write that down here. 20 milliamps for I1 and I2. And what's that?
This is what you want to you suggest we do all of this before we actually do the calculations for the breadboard, so we can see if they're close.
These are the calculations. So I would recommend that you do the calculations and that you build the circuit.
Yeah.
You can do it in either order that you like. You could build the circuit first and make your measurements, and then check the calculations, or you could do the calculations first and build it after.
The only reason that we have to do both is just to compare and see if we're close.
Right. That's yeah.
Okay.
Yep.
But what really matters is it what we register on the breadboard?
The right answer is what matters.
Yeah, but what we get on the breadboard.
I mean, if
Or like if we just did the entire thing just via this, is that fine?
it should come out the same.
Okay.
So as long as you get the right answers, it doesn't matter which way you do it.
So if we didn't want to, we don't even need to use the breadboard.
You don't have to. Again, I recommend that you do both to check your work, but it's up to you.
Isn't the point to learn how to do both?
I mean, yeah, that's the goal of the class, but I can't. I'm not going to be sitting over your shoulder and checking everybody and making sure that you're plugging the resistors in and doing it. I can't do that. So it's up. I highly recommend that you do both, though, and we will go over the breadboard in just a minute. But before we do, I just wanted to point out one more thing, which is that. So we've got 20 milliamps flowing here, and then that current comes to this junction here, right? And we said that we looked at Kirchhoff's current law, right? And that says that all of the current flowing into a junction must be the same as the amount of current flowing out of that junction. So let's take a look and see if that law is holding up here. So how much current do we have flowing into this junction?
20 milliamps.
20 milliamps. And flowing out, we have 13.3 over here and 6.67 over there. So do those two together add up to 20?
Not exact numbers, yes.
But yeah, darn close. Close enough to the point where, yeah. So that's another way that you can check your work when you're doing your math. The currents that flow through the two right resistors should be, when you add them together, they should be the same as this total current that's coming out of your power supply and flowing through the top and bottom resistor. So that's one thing to check. Another thing is the voltages. So again, when you add up So the voltages around any loop should add up to 0. So that's not the same as saying that V1 plus V2 plus V3 plus V4 has to be 12, right? It isn't. But the voltages around any loop have to add up to the power supply voltage. So that's another way that you can check. Yeah. So any questions about that before we move on and do the physical thing? All right. So yeah, so let's do the fun stuff, the actual building here. Yeah, there it goes. Okay, so when you do your test, you'll get a diagram, something like this, and you'll be given resistor values. So the first thing that I recommend that you do, you go grab your resistors and then actually measure each resistor by itself to make sure that the resistor value is what you think it is. Because even if you pull a resistor out of the 1 kilo ohm resistance bin, that doesn't guarantee that it's a 1 kilo ohm resistor. Okay, people put resistors back in the wrong bins all the time by accident. So the first thing I would recommend is that you actually measure your resistors and your resistor values using the meter. So remember, the way to do that is you put the black lead in the common port, like always. You put the red lead over here in the rightmost port where it indicates resistance. Then you put the dial into resistance measuring mode. So that's one of these positions over on the left-hand side. And then you just grab the resistor in the 2 leads from your meter. So you hook it up like that, and then you check to make sure that the value that you're reading is the actual, it corresponds to what you think it should be, okay? And then you can actually write that down. Yeah?
In my classroom, I began having problems with the clip leads. And where they go into the meter.
Yeah.
And they've been bent enough. They used like a number 40 wire in some of those new ones.
Oh boy.
And they have been intermittent. So you look at it, it'll be 12.97K. You move it a little bit, and it may be 3 point something K. So you might want to check those leads. If you do start having problems, that could be what it is. Because they should be steady like Jordan has them. But
yeah,
I've had that quite a few times. I had to have them replaced.
Yeah. Okay, so yeah, that's an excellent point. Thank you for that. So like Fred said, the number on your meter should be pretty constant. Even if if you wiggle it around a little bit, maybe the last digit might change a little bit, and that's okay. But anything more than that means that you've got a problem somewhere with your measurement system, whether it's the meter itself or the leads, or sometimes you're just not clipped onto the resistor very well. But if you see the number fluctuating a lot, like 12 to 6 to 4 to 8, if it's changing like that, something's wrong. You gotta. So first of all, check the connection to your resistor, and if that's good, it means there's a problem with your meter or your leads, and just, I would, if you're in the middle of a test and you see something like that, just get brand new meter, brand new leads. Just don't even futz with the old one, okay? Because you've got enough to deal with it already. So, yeah, so very good.
The frustration that it's not them, it just keeps moving back and forth.
Right.
As they move them around,
Right.
it comes in and out.
Yeah, yeah. So, and you're welcome to get another lead, another meter, another set of leads if that happens. Okay. So, all right. So first of all, measure all 4 of your resistors. Make sure that the values are what you think, and you can write down their actual resistance values too. So rather than just calling this a 13 ohm resistor, you could write down 12.97 kilo ohms. And then the more precise you are in writing down the actual values, the closer your math will be to your measured values. All right, so once you measure all of the resistances, then it's time to start building your circuit. Now there are 100 different ways, 1,000, a million different ways you could build this circuit on the board and get the correct answers, but what I like to do is I like to try to make the circuit look the way it does in the diagram so that you keep things straight in your heads. Because if I put the resistors all over the place, I quickly forget which one is which. Okay? So I look at this diagram, I see that power supply is on the left. So what I would do is I would hook up your leads for your power supply over on the left side of your board. So it would be something like this. Now on the actual circuit, you'll have real numbers. So this would be like a 1 kilo ohm resistor, say, maybe 2 kilo ohm down there, and 5 kilo ohm, 10 kilo ohm, maybe. Something like that. On your actual test, you need to make sure that you take the 1 kilo ohm resistor and put it in the in the top spot on your circuit. Seems like it should go without saying, but people have said, well, I just put all the resistors in the board and it didn't work for me. Well, you put the 1 kilo ohm over here and you put the 5 kilo ohm down there, and yeah, you got to put them in the right places, okay? So I put the 1 kilo ohm resistor up there. I would put the 2 kilo ohm resistor down here on the bottom. And then I would find the 5 kilo ohm resistor, and I'd put that in the middle here. And then the 10 kilo ohm resistor would go over here on the right-hand side. And now we need to make a connection between this resistor and this resistor over there. You can see that there are wires that go from the top of this resistor to the top of that one. So we can use a jumper wire for that and make that connection, and the same thing on the bottom. So this is one way to build a circuit. Like I said, there are a million different ways to do this on the board. You're free to do it however works for you. This is just a way that works for me that seems to keep things straight. It makes the board look similar to the diagram. Okay? So that's how you can build your circuit. Okay? Now, you have to find the total resistance for this circuit. So one way to find the total resistance for this circuit is, before you connect your circuit to the power supply or anything else, you just grab your 2 leads here and you measure the resistance with your meter. Okay? You still have the meter in resistance measuring mode. You just hook up the meter to those two leads, and now that's your total resistance. Oh, now it's bouncing around, like we said. So that would be the total resistance for this circuit, okay? So that's how you can find the total resistance. Then after you do that, you can hook up your power supply, and you can start to measure the voltages and the currents. So I would measure, well, you can measure them in any order you want. If you're going to measure voltage, is that a destructive measurement or a non-destructive? Non-destructive. So remember, voltage is just in parallel. So so we can just hook up. You can attach the leads directly to the resistor and measure voltage that way. But that does have a tendency to pull resistor legs out of the circuit. So what I recommend is that you grab a little jumper wire in each of the alligator clips on your meter, and then you just plug in those little leads where you want to measure voltage. So if you want to measure it across the resistor, you just plug in the leads at the two ends of the resistor, and then you measure your voltage. Okay? So, and then you just move that around and measure the voltage across each of the resistors. So that's how you can measure the voltage in your circuit. Again, you need to have the power supply hooked up when you're making those voltage measurements, because the power supply provides the voltage to your circuit. So, questions about measuring voltage? All right, and then the other thing is that you want to measure the current for your circuit. So the way that you measure current is you have to partially deconstruct your circuit. So, and then you attach your meter to the two loose ends of the circuit where it was taken apart. So for instance, if I want to measure the current through this resistor here, when I want to measure the current through any resistor, I just pull out one leg of that resistor. I hook the meter, one lead of the meter onto that leg of the resistor, and then the other loose end of the circuit is where that resistor used to be connected. So I would plug in a wire where that resistor used to be, and then I'd hook the other lead of the meter onto that wire. Now, when you're measuring current, the meter needs to be in current measuring mode. So that means you need to move this red lead from the voltage port over to the current port. The black lead stays in common like always, but the red lead moves over to the current port, and you put the dial into the current measuring setting. So that's one of these two positions on the right-hand side. And now you're measuring current. So you measure current there. When you're done measuring current, put the circuit back the way that it was before you make any other measurements. So disconnect your meter and put your resistor back where it was before you start making any other measurements. Okay? And then you can just repeat that for the other resistors. And to measure the total current for the board, the total current is the current that's coming out of the power supply. So you would have to break the circuit apart where the current comes in from the power supply. So the current is coming in from the power supply on one of these jumper wires here. So to measure that current, you could take the jumper wire out, connect one lead of your meter to that jumper wire, and then plug in another jumper wire where the first one used to be, and then connect your meter there. And that would be how you would measure the total current for the circuit. And again, when you're done, take your meter off and put everything back the way that it was before you go on to your next measurement. So that's how you can build a circuit on the breadboard and then make all of the measurements that you need. Any questions about that? Yeah.
I find this interesting. This is the first time I've ever sat through Jordan's class. And would you believe Jordan and I went to school together? Why are you laughing? Okay, it's really interesting. He went through and showed you exactly the same way I would have done. And that doesn't come from school. That comes from building millions of these. And I think by listening to what Jordan said, we've refined this down to saving you guys hours and hours of working on this. And if you were to learn in school by somebody that hadn't taught it 1,000 times, or not taught it, but done it, I think they would have showed you a complete different way that after about 10 years or 15 years, you would have finally figured this is the way to do it to save you a lot of time and trouble. And it's real weird. Jordan's building it and I'm building it.
There you go.
You went through it the same way.
There you go. Cool.
For what that's worth.
Well, hey, I'm honored if I can do it the way that you've learned.
I've made mistakes.
Oh, no. So that's a good way to build it. The last thing I wanted to show you was I wanted to show you a little bit about the actual quiz online. Just show you a couple of pointers there for entering your data here. So under actually, I believe that this is under assignments. So we got the lab quizzes here. So the practice online midterm, that's when we go over to the lab, this is what you're going to do. You can also do this at home if you want. So the first thing you see when you pull this up is the all the rules. And then you will, when you're taking the test, this is what you'll see. So it shows you the circuit diagram here, and then at the top it shows you which resistor values to use. So R1 in this case is 1,000 ohms, R2 is 2,200, and then so on. And then down here is where you enter your values. So each one of these values has a unit next to it. So you need to make sure that you put your answers in the correct units. So down here, the total resistance is in ohms. So if I had, say, a total resistance of 10 kilo ohms, I would have to put down 10,000 ohms. Okay, I can't just put 10. I can't put 10K. It doesn't like abbreviations either. If you put 10K, it gives you this warning, it's not a decimal. So you need to actually put 10,000 because it's 10,000 ohms. Yeah?
So if it's a really large number, would this accept engineering notation, or do you just have nothing that's going to be so large that you need that?
Yeah, the short answer is that it won't be that big.
Okay.
But also, I don't think that it will accept engineering notation.
Okay.
Similarly, down here for the current, all of the current values are in milliamps. So you need to put your answer in milliamps. So if you have 0.002 amps, you need to convert that into 2 milliamps, and you just put down 2 for 2 milliamps, okay? So make sure you're using the correct units, and then voltages are all in volts. So you just put in whatever you measure. So when you're all done, you click Submit and End. And it says after submitting, you won't be able to change your answers. Remember, the midterm, you only get the one chance. So you want to double check your work before you say OK. And you say OK. And then it grades it automatically, and it shows you your score. Looks like I actually got one right. Never happened before. Yeah, thank you. So that it's kind of useful, but especially when you're taking the practice and when you're working through this, you might want to know which ones you got right and which ones you got wrong. So if you click over here on this tab that says Review Questions, that shows you.
You said we can take the practice as many times as we want.
Yes, you can take the practice as many times as you want. You can do it at home also. So when you are done taking the test, you can go and do this review as well. Boy. So yeah, so you would submit, and then you would review, and then this shows you your answers down here. It shows you which ones you got right and which ones you got wrong. But then there's this little key at the bottom. If you click on the key, it shows what the computer thought the answers should be. These are the correct answers that the computer calculated. So you can check and see how close you were. So this can be helpful when you're reviewing your answers to see which ones you got right, which ones were not quite there, and what the computer thought the answers should be. Okay? So that's what I wanted to say about the online test. So are there any questions about that? Yeah.
Yeah, I don't know if you talked about this yet, but so each person's going to get a different set of resistors, so the computer will know, like, it'll correlate what we have.
Yes.
Already, so it won't. Okay.
Right. So it will tell you which resistors to use up here. You can see that even these numbers are different even than the last time that I did it. Every time you do this, you'll get a different set of resistor values. You need to use the ones that are specified up here because the computer will use that when it's calculating its answers. Yeah.
Thank you.
Sure. Other questions? All right. Okay, then let me take attendance and then we can go over and actually practice.